We move on to the fifth lesson in the module 2. The fifth lesson is about rhombi and squares. Now, we have learned parallelogram. So this is parallelogram, something like this. Okay, that's something like this. We know rectangles which have 90 degrees every way. Now we will learn two more things, rhombi and square, which are parallelograms, but they can be classified differently into rhombi and squares if they meet certain conditions. We will look into this lesson, the learning objectives first, recognize and apply the properties of rhombi and squares, and to determine whether quadrilaterals are rhombi or square. Now the keywords over here are rhombus, square. That's it. Now the properties of rhombi and squares. First thing we will look into what is a rhombus. Rhombi is generally called for as a plural form. Rhombus is specifying this. Now rhombus over here, as you can see, is a parallelogram. Yes, but all the sides are equal. The consecutive sides, can you see this? All the consecutive sides are equal. But it's not a square. Why it's not a square? Square is something with 90 degrees everywhere, right? It should be 90 only. But this doesn't require to be 90. Only thing is all the sides are equal. The sides can be 5, 5, 5 and 5 over here. But they do not need to be equal. I mean, the angles do not need to be right angle. Now, what about the other properties? There's one more property about the diagonal. When you draw the diagonals, here it will be 90 degrees. That's fine. But the another important one is it will bisect the opposite angles. Now this angle is there, right? Whatever is the angle, if it is 80, it will bisect it equally. Bisection means making it to half. It will become 40 and 40. If this is 30, then the other angle is 30, equal. So that is what it does. So we can see there are two theorems. If parallelogram is rhombus, then the diagonals are perpendicular. Okay. If a parallelogram is rhombus, then each diagonal bisects pair of opposite angles. That is what I told, the two things. Now, a square you can see is similar to a rhombus, but it has 90 degree all the sides. And over here, what are the extra things? Basically, the diagonals are congruent to each other. Yeah, that's it. So we will see problems on them. Now here you can see they have told LM is 2x minus 9 and KN is x plus 15. And they have told this is a rhombus. What is the value of x? LM and KN is given. So LM is 2x minus 9. That must be equal to Kn, that is x plus 15. Solve this and you'll find the value of x. You can directly solve this in calculator with using alpha x. Otherwise, we'll solve it over here. This 2x is bigger, so this x comes over here, minus x. And minus 9 to the other side becomes 15 plus 9. And you're remaining with x equals 24. So answer is 24 here. So that's the answer, x value. They have just asked you to solve for x, that's it. Now let's see another problem. Here we have to solve plenty of things. First, let's see what is given. AZ is given to be 14, this value, okay? AZ, this to this. Okay, and then ZY, where is ZY? This value is 22. And they have given the measure of W, Y and Z. W, Y, Z is 35. So what do they want? They want Y, X and Z. Where is X, Z? X and Z is this. If we know half of it is A and Z, we should just multiply this by 2. Why? Because they have told it's a rhombus, so then this will be twice. This and this is equal, right? So 14 times 2 or 14 plus 14, it's 28. So the answer is 28 over here. What about the other measures? Let's see. Measure of X, Y and Z. This entire measure. Now I have told a while earlier, it bisects each other. So if this is 35, even this is 35, the total angle is 70 here. 35 plus 35, it's 70 degrees. And the last one, WXZ. So let's see W, X and Z. How would you solve this? This is the angle required. So we don't need this side even if we solve ZXY is the same thing because they're congruent. So let's just find this. Now the diagonals are always 90 degree. They intersect each other at 90 degrees, so all these diagonals are 90. We know this 35, this is 90, and the total is 180. So this is unknown x value, right? Let's solve. X plus 90 plus 35 must be equal to 180. So it will be x equals 180 minus 90 minus 35. You can do it in the calculator. It's negative 125. 125. Sorry, negative 125. 75. It'll be x equals 55, if I'm not wrong. Yeah, 45 degrees. Okay, just this calculation. So this is your answers. So you should know what is given and see how we can find the other one, and easily can solve them up. Now we will go to the example 2. Here, the diagonals of the rhombus KLMN intersect at P. If the measure of LMN, where is LMN? Okay, this is LMN, is 75. Find KN and P. Okay, K and P. This is the measure we need to solve for. Now we know this is 75. So how much is this? Half of 75. That's 37.5. Now this is 90. So use the angle property. We can find K and P same as P and M, right? We'll find this x, then this is equal to this because it's rhombus. 180 I'm directly writing minus the known values, 90 minus 37.5, that will be value of x. So here it would be 180, it will be 90 minus 37.5, so it will be 52.5 degrees. X is 52.5 degrees. Yes, that's it. K and P. Why? Because P and M and K and P are same. So if you find one side, that will be the same thing. You can just correspond. It's 52.5. There are other methods to solve as well. Some long methods, some short methods. Whichever is easy, whichever is direct, just follow which you find comfortable. Okay. And now here we have a square where they have told FJ, this is the FJ side, is 19. Okay, what is FH? The total angle. So 19 times 2, it's 38 degrees. You don't need to solve a lot. It's just add them both. It's 38. Why? 19 times 2 is equal to 38. It's very straightforward. There's nothing much in this. I hope you remember the diagonals intersect each other and they bisect each other. So this and this are equal. Okay. And now in rhombus PQR, PQ is given to be 4x plus 3 and QR is also given as 41. Measure of PQT is given as 2x plus 4y. We need to find y. First thing, this is a rhombus, so the sides are equal. So you can find x. See, we can't directly solve this because why? This is unknown, x and y are there, but we can solve these two, PQ and QR. They both are equal. 4x plus 3 must be equal to 41. And now solve for x. 4x equals 41 minus 3, it will be 38. Divide both the sides by x. X will be, this will be 9.5, I believe. Yeah, it's very close to 9, yeah, 9.5. So now x is 9.5. What about this y? Let's see now about y. Here, okay, see, I forgot to read this. What must be the value of y if the rhombus PQR is a square? That's what I was wondering. And it looks like a square. Now you can't solve otherwise. This is given. Now they have told this must be a square, right? So square means this is 90 degrees. But you know only PQT, this one, that is 90 by 2, that's 45 degrees. Okay, so we know measure of angle PQT is equal to 45 degrees. That is 2x plus 4y. Okay, they have given it. Now, you know what is the x value? Just substitute and solve for y. It will be 2 times x, 2 times 9.5 plus 4y. That will be equal to 45. You can solve it directly in calculator. 4 and y, sorry, this is y is unknown. Now here 2 times 9.5 would be 19. Take 19 to the other side, it will be 45 minus 19 equals 4y. Now it will be 26 equals 4y, and divided by 4, it will be 5. 6.5 is y. That's the answer. I hope it's correct. Okay, 6.5 is the correct answer. This is 6.5. So what we do, we first have to equate these both and find the x value, and then substitute the x value in the angle value. But the angle is not given. We have been told it's a square. So squares ends are always 90 degree, but half of that is 45, and equate it and solve it at 6.5. That is how we solve it. Now then, tests for rhombi and squares. Rhombi is the plural of rhombus. If many rhombuses are there, we call it rhombi. If one rhombus, we just call it rhombus. Okay, more than one, rhombi. If a parallelogram meets certain conditions, you can conclude that it's rhombus or square. Now, okay, these are the ones. If the diagonals of parallelograms are perpendicular, then the parallelogram is a rhombus. Yes. If the diagonals are, the diagonal is diagonals are perpendicular, like these are 90 degree, then yes, it's a rhombus. If one diagonal bisects, see if the diagonal bisects the angle, then yes, opposite angles, then yes, it's a rhombus. If two consecutive sides are consecutive sides of parallelogram are congruent, that means if two sides are equal, then it is a rhombus. And if quadrilateral is both rectangle and rhombus, then it is a square. See, square and rhombus are very close. Only the thing is, it's not 90 degree, So in rectangle, this is 90 degree. So then that is a rhombus. Square, sorry. Let's write paragraph proof of here. What do you want? Given is TUVW is a parallelogram. The triangle TSW and TSU are congruent. They are congruent triangles. So we need to prove this is a rhombus. Okay. There are various ways to prove this, because now they have told this is congruent to this. How can you do it? All the congruent parts are equal. You can tell this and this is equal, this and this and this angles are equal. So various ways to solve, but the easiest way is, the consecutive sides, right? If two consecutive sides are equal, then it's a rhombus. So TSW and TSU over here, triangles are congruent. That means congruent parts, sides are also equal, right? TW and TU will be equal. So it's a rhombus. Yeah, that's what is done. TW or WT and UT are congruent. Why? Because they are congruent triangles, and that is given. That theorem is there. If consecutive sides of a given parallelogram are equal, then it's a rhombus. That's the thing. And that's the first one we saw over here. See, so sorry, the third one, this one. Now we will see one more problem, real world problem. Ananya is designing a sweater using an Argyle pattern. Now, this term Argyle means anything that's related with diamond shapes, So this is Argyle pattern. All four sides of the quadrilateral ABCD are 2 inches long. How can Ananya be sure that the Argyle pattern is a square? Now here, this pattern over here is told, see, this is 2 inches. All the sides are 2 inches, okay? Now this is the figure, 2, 2, 2, 2. But what we need to know is, how can we tell it's a square? So all the sides are equal, okay? Now you can see the opposite sides are equal. Yes, that is good. But now, if we need to prove this to be square, first we need to prove it that it's a parallelogram, and then it must be a rhombus and a rectangle. Then only we can tell it's a square, right? So because both the opposite pairs of sides, see, this and this is equal, this and this is equal, it's a parallelogram. Very easily we can tell it. Whenever the opposite sides are equal, It's a parallelogram. Now, next one, because the consecutive sides are congruent, can you see this and this side? Consecutive are congruent, it's a rhombus. If it's a parallelogram, then any two consecutive sides equal, it's a rhombus. Now, what about the rectangle? Rectangle, now we can't prove it's a rectangle. We can, when we prove I mean, if it's a rectangle, it will automatically be a square. How do we prove this is the diagonals. Only in rectangle and square, these diagonals are congruent. Okay, if this is phi, then this also will be phi. So we have to just prove the diagonals to be congruent. Now, you can do is, if now here we cannot solve it, but we are just telling how to prove it. So if Ananya measures the length of each diagonal, she can find, if she finds it's equal, then it's a square. We are just suggesting. But if the coordinates are given, say you knew the coordinates, you can use the distance formula and find this distance and this distance, and you can measure the diagonals and conclude it. That is how we could do this. And now we have another problem, classify parallelogram using coordinate geometry. Now this, they have given this coordinate. Here they have told the coordinates of A, B, C, D. Is it a rhombus? Determine whether it's a rhombus, rectangle, square, or a parallelogram, or none. List all that apply and explain. So now, first of all, we need to see whether it's a parallelogram. How do you understand it's a parallelogram? If you measure the distance, or now since it's in coordinate grid, it's very easy. Let's see the slope. 1, 2, 3, 4, and 1. Over here, 1, 2, 3, 4, and 1. Here it's 1, 1, 2, 3, 4, 1, 2, 3, 4, and 1. Yes, it is. All the sides are congruent, so it's directly I can tell it's a rhombus. Okay, why? Because all the no, I can't directly tell it's a parallel. I can tell definitely it's a parallelogram. All the four opposite sides are parallel to each other and everything. And now, oh no, I can't tell it's a rhombus. I'll tell you why. See, look at this figure, guys. Is it 90 degree over here? No, it's less than 90 degree, right? So rectangle and square are gone out of the ballpark, because you can't make this rectangle or square. It's not 90 degree. This is not 90 degree. This can never be rectangle or square. That's not possible. But we can prove this to be a parallelogram. You can see the opposite sides are parallel to each other and they're equal. If you count the slope, we can just see that opposite sides both are equal to each other. That's how we can tell it's a parallelogram. But here, if you see the slope 1, 2, 3, 4, and 1, same thing over here, 1, 1, 2, 3, 4. That means these both are congruent to each other. So that is why you can also tell it's a rhombus. Or there are other ways to solve as well. Let's see how did they do in the textbook. Now, okay, this only can be rhombus, okay, or parallelogram. It can't be, any other things. It can't, that's what it says. It appears to be a parallelogram and it can be a rhombus. Now, what they are doing over here is understood slope AC. This is also fine. You can find the slope between these 2 points and these 2 points. Okay, and if the slope is if this is 90 degree, that means the slope of each other when you multiply will be -1. So if you get that, then yes, you can prove this is a rhombus. Okay, this is one way. But what I told you just now, since all these sides are equal, you can also tell it's a rhombus. But you should just mention that properly, why it is equal. Why? Because 1, 2, 3, 4, 1, they're all corresponding to the same slope and sides. And from Pythagoras theorem also, you can prove that there is 4 and 1 over here. You can use Pythagoras theorem to prove the side. And here also it is 4 and 1 from Pythagoras theorem. Oh, now let's do the slope thing over here. AC, what's the value of A? It's 1, 2, 3, -3, comma 2. And what is C? It's 1, 2, comma Y is 1, 2, 3, 4, 5, 6, 7. Okay. Now all you need to do is plug in the values. It's y2 minus y1, 7 minus 2 divided by x2 minus x1, 2 minus of -3. So the answer is phi divided by minus of minus is plus, again phi, it's 1. Now you should find this B and D, so it's minus 2 And what is the y value? 1, 2, 3, 4, 5, 6. Minus 2 and 6. Here it is 1 and 3. So these are the coordinates. Now we will find the slope of BD, diagonal BD, okay? So that would be y2 minus y1. You can take any of it. It'll be the same answer. I'll just take this. 3 minus 6 divided by 1 minus of minus 2. The answer is over here. 3 minus 3 divided by positive 3. It's minus 1. Now you can see it is the negative reciprocal. You know that if you have a slope, say 2, and the other slope is minus 1 by 2, then they are perpendicular to each other. You can find they to be perpendicular to each other, right? The two lines. Now here, this line and this line are perpendicular to each other. Why? 1 and minus 1. That means they're negative reciprocals. That is the thing. This is negative reciprocal. Now we can prove like that. We can say it's 1 and minus 1. So hence the slopes, the product of the slopes are negative 1, and hence the diagonals are perpendicular. So if the diagonals are perpendicular, it's a rhombus. Whereas if it's a parallelogram, it may not be perpendicular. So there are various ways to solve this. Ultimately, you'll get the same answer, and that's it. This is about rhombus and squares. So rhombus is similar to a square. Only thing is it doesn't have 90 degrees. But if you see a parallelogram which is same like rectangle and a rhombus, then it's a square. So that's it. If you have any doubts, please post them in the comments and I'll get back to you. And until the next video, take care and bye-bye.